Now we come towards certain applications. So there will be first example. At what height above the Earth's surface does the force of gravity decreases by 10%? 10% means 10 over 100, that is 1 over 10. And the radius of Earth is exactly taken as 6,370 kilometers. Normally, if the numbers are not provided, we take it as about 6,400 kilometers. So we have to find the height above the Earth's surface. That is from the circumference, how high the satellite is moving. The force of gravity decreases by 10%, assuming the radius of Earth to be 6,370 kilometers. Now to solve this question, the force of gravity at surface of Earth, that is given by formula, that is gmm over r square, and it is marked with F1. Then the satellite is taken to certain height h and the force becomes F2. Now in the numerator it will remain the same, that is gmm, but dividing by not simply r square but r plus h whole square. Now this is the second equation. So what we are doing is, that is we are dividing first equation by second equation, that is F1 over F2, and towards the right side we will write gmm will cancel off. It will become F1 over F2, so it will become r plus h whole square over r square. And then we will simplify this result to get the value of h. So after elimination of all other values, we find the height at which the satellite is moving is r into F1 over F2 under root minus 1. And that is given to us, that is 350 kilometers. So h is equal to r equal to under root F1 over F2 minus 1, and that is equal to 350 kilometers, where F2 is 9 times of F1. Now in the second example we find the mass and radius of the Earth. Mass and radius of Earth and Moon are m1 and m2. So mass and radius of Earth and Moon. m1 stands for Earth, where m2 stands for Moon. r1 is the radius, it stands for Earth, and r2 stands for Moon. Their centers are at distance d apart. The minimum speed with which a particle of mass m would be projected from a point midway between the two centers so as to escape to infinity will be how much? So in order to solve this question, we know that potential energy of the mass is half of the original value due to Earth and Moon. So it is given in the question. So the electrical, that is gravitational potential energy, that will be calculated as minus 2 gm1m by d, and then minus 2 gm2m by d. So we take out the negative sign common and we put a plus sign in between, and we take out common as gm over d. So gm over d is taken out common within the brackets. It will be m1 plus m2 numerically, but at the same time u is equal to half mv square, that is the potential energy. So we can write like this, that VE, escape velocity, is how much? So we put in the equation of escape velocity the given values. So what we have done, that half mv square is equated with minus 2 gm by d into m1 plus m2, and from that we have made the subject of equation as VE, and that is found to be 2 under root g over d m1 plus m2. Then in another example, now the diameter of the planet is given, that is diameter, that is twice the radius. The diameter of the planet is 4 times that of Earth. If Earth has diameter d, then the planet has 4d. The time period of pendulum on the planet, we have to estimate the time period of pendulum. Normally pendulum has a time period which is 2 pi under root L over G, and if it is seconds pendulum, then the time period is taken as 2 seconds. So our question is, if it is seconds pendulum on the Earth, will we take the mean density of the planet equal to that of Earth? So our net question is that diameter of a planet is 4 times that of Earth, and seconds pendulum, that is, we have to find the time period of the pendulum on the planet if it is a seconds pendulum on the Earth. So when we say seconds pendulum, its time period is 2 seconds. So making a solution to this question, it will be proceeding like this. If r is the radius of the Earth, then radius of the planet is 4r. This is what given to us. Another thing, acceleration due to gravity on Earth. Small g is calculated by gm over r square. Now we kept g as it is, and for mass we have kept density. We know that mass is density into volume, and r square is kept as re square. When we speak mass, it will be density into volume. Volume of Earth will be taken as 4 by 3 pi r cube, and density is taken as rho. So this is equal to 2 pi r rho g divided by 3. 4 over 3 can be written as 1.33. So acceleration due to gravity on the planet. So this is how we estimate the acceleration due to gravity on the planet by computing the values. So what exactly we have done? That g is kept as it is, r is kept as it is, only mass is converted, that is density into volume. So density is rho, but the volume is 4 by 3 pi r cube. So we will find g dash on the other planet. It is gm over 4r whole square. It is exactly the same as we have written earlier, g is equal to gm by r square. So g dash is gm dash over 4r square, and it is equal to g as it is, and the remaining value will be of the density. So we have computed that value, and final result will become 16 pi r rho over 3 into g, the time period of the pendulum on the Earth. That is, 2 is equal to 2 by under root L over g. T is the time period of pendulum at planet. Then T dash is 2 pi under root L over G dash, and for G dash we will compute the value, and that will become T dash over T. Now we estimate the value of T dash, and that will be 2 multiplied 1 over 2, that is 1 second.